All right. So good afternoon again. This part of the event is a slightly bit more academic. I just would like to give you the flavor of what is it like to study here at our school in one of my subjects. As I told you before, I've been teaching microeconomics, game theory, and experimental economics for many years here, actually since 2010. Also, when it comes to research, what I do is to work with experimental data. I do like theory, that's where I get my motivation from, but I would like to try to test those theoretical predictions, those theoretical models, and in order to do that, I collect my own data. You will see in a moment how we do that. I use statistics, and with those empirical results, maybe I can support the theoretical predictions, or maybe I can reject them, and then I try to improve the model. Okay? And for this talk, for this event, I chose a topic that is related to Japan. It's a story about peer punishment and free riding in social dilemmas. Fancy words, fancy terms. Don't be frightened. I will explain them in a moment. Let me start by explaining the last part of the title. What do I mean by social dilemma? You might actually have heard about social dilemmas while reading a newspaper, a magazine article, or maybe while studying at high school. It's actually a problem that reappears all the time. If you are interested in social sciences, if you are interested in how society works, I'm pretty sure you have encountered this term before. Sometimes it appears in different disguises. In political science, maybe they don't say social dilemma. They say, well, let's think about the irrationality of voting. Why do people vote? Why do you participate in general elections if there are so many other people and it's not very likely to be the case that your vote will make a difference, right? You pay a cost, maybe it's a weekend, you have to go to the voting booth, you have to collect information, and at the end of the day, there is not much of a difference that your vote is going to make. Psychology, they liked talking about the prisoner's dilemma that actually also appears here in economics. Today I'm going to talk about this free rider problem because it's a slightly bit more general version of the prisoner's dilemma. Instead of just two people, we will be having more than two. You will see four or even more people. And instead of just two alternative actions or strategies, you will have a larger possible set of decisions that you will have to consider. And I like this way of referring to social dilemmas. I found it in a recent microeconomics, graduate level microeconomics textbook written by Samuel Bowles, published in 2006. He talks about the classical conundrum. It's one of those big questions. It's one of those eternal questions, if you like, that social scientists, economists as well, have been asking and trying to answer for a long period of time. What is the story about? Well, the story about is actually free riding, and the story about is about public goods. In economics, we usually talk about four different types of goods. Here you have a typical example for each of those types. If you have studied some introduction to economics at high school, maybe you already know the answer, but let me just explain for the sake of a better understanding of the future results, that we talk about public goods when the good is non-excludable and non-rival. It means that public goods will have to satisfy, basically, they'll have to have two properties. We have two properties. The question is the good excludable or not? Is the good rival or not? The answers are yes or no, and that's how we have actually four possible types, four possible categories. We say that the good is excludable if it's easy to say that, well, you get to consume this good, but you don't. Okay? You can exclude some people from consuming this good. We say that the good is rival if, for example, my consumption reduces your possibilities of consumption. Let me give you an example with the help of those pictures. Let's go with the easiest one. This is bread. This is the typical consumption good. This is a typical private good. Everybody is familiar with it. It is excludable and it is rival. Why is it excludable? If you don't pay the price, the bakery will not give you the bread. it is rival. Why? Because if I eat a slice of this bread, or if I eat half of this bread, your consumption possibilities are reduced. Okay? But now we can go around, look at the other examples here. I just took a picture. Let's suppose this is a train at a train station, and not too many people are around, so this is not a rush hour in Tokyo. We could say that in this case, the good is excludable. Why? Because you can see these gates, right? If you don't pay the price, you are not getting in. But it is not rival. It's not rush hour. Even I'm riding on this train, you can still catch the same train and get to your destination. Okay? I think that's a fine example. And we usually call this type of goods as club goods. You have to be a member, you have to pay, but after that you are not in rivalry with the other users. Let's move here. These are fish. Let's suppose in the ocean, it's not a private lake, it's not a private tank. So these fish, let's say, do not really belong to anyone in general. These goods, for that reason, are not excludable. They are non-excludable. If I have a boat, I can go and try to fish. These fish don't belong to any country or any particular enterprise, let's say, but they are rival. If I catch some fish, you are not going to be able to catch the same amount of fish, right? So if I catch some fish, your consumption possibilities are reduced. And finally, we have reached this part. This is the true public good that you can imagine throughout the talk. This is a lighthouse. What does it do? It emits light. So it helps navigation. You have a boat, for example, you would like to approach the port, or you would like to avoid dangerous areas, and this is the light that you can take as a reference or follow as a guide. This is a typical non-excludable good. Even if you don't pay, even if you did not contribute to the construction of this lighthouse, you will be able to see the light that it emits, and it is non-rival. Just because I see this light, you see exactly the same amount of light. And that's what we call as a public good. So as I said, this was a private good. This is a club good. I forgot to tell you, we call this type of goods as common pool resources or common goods. And finally, this is the main idea here. This is a public good. Non-excludable and non-rival. And as I said, social dilemmas are recurrent problems. They are everywhere in social sciences. I've collected here a few quotes from very, very old but very famous works. These are from the late 60s. Olson, very pessimistic view. Non-excludability means that the logic of collective action leads to the non-provision of public goods on a voluntary basis. Remember the idea of non-excludability. Even if you don't pay, you are still able to enjoy this good. For that reason, Olson was saying that, well, we have to be, or we cannot expect these goods to be produced or provided because people will have incentives to free ride. They will want to enjoy without actually paying, contributing towards these public goods. Same here, Buchanan. The provision of a public good is problematic because each individual can at least temporarily free ride, that is, secure the benefits without contributing to the costs. Once again, a very, very pessimistic view. Here I just copied the expression that we very often use in economics. We talk about the tragedy of the commons. It seems really, really hopeless. We cannot actually rely on a private provision of these public goods because non-excludability leads to free riding. So in the end of the day, nobody will have incentives to work and provide these goods. I skipped the slide, but let's move to the model itself. And this is the moment I would like to frighten you a little bit with mathematics. As I told you in the previous part of the talk, political science and economics are social sciences that use a systematic approach, sometimes a very abstract approach, to analyzing and making sense of the problems in society in general. After this brief introduction, after giving you the definition of what is a public good, I would like to build a simple model, and I would like to even solve it in front of you, okay? Or maybe with the help of you. Let's see. What we are going to build, what we are going to describe is the so-called linear public goods game. It's possibly the simplest way to think about public goods and the simplest way to get those very, very pessimistic, negative conclusions that I have summarized on the previous slide. Now, let's suppose that we have n people, okay, n decision makers working together in this society, n people who will have to decide whether to contribute or not to this public good. And let's suppose that everybody starts with 20 monetary units, 20 tokens as initial endowment. It could be, I don't know, maybe 20 million yen, some amount of money that you have or you have worked for a number of years. And let's suppose that the decision that people have to make is fairly simple. They just need to decide what to do with these 20 monetary units. They have to decide how to split the initial endowment, and they have two options. They have something that we can call as the private account, and they have the public good, let me call it as the public account. You have some amount of money, you have worked for it. Now the question is, how much would you like to keep in your pocket on your private account that you can later on dedicate to private consumption, and how much you would want to give to this public account, how much would you want to contribute to this public good, okay? And of course, if you keep something on your private account in your pocket, that's yours. It doesn't disappear. If you give some amount of money to this public account, it will contribute to the public good, we say that this public project will generate some return. This MPCR is the marginal per capita return, and I chose a number 0.4. Let me just tell you how to make sense of that. So let's suppose that this is your contribution, C. It means that you decided to keep in your pocket 20 minus C. Okay? I'm talking about n different people. Just to make sure that I understand who is who, let me use a subindex. Let me talk about person 1. Okay? There are many n minus 1 other people, but person 1 decides supposedly to contribute C1 units of money to this public account. So it means that this person 1 keeps 20 minus C1 units of money in his or her pocket in the private account. This amount of money is to be enjoyed directly, but what goes to the public account is going to be aggregated. Person 1 decided to contribute, but also person 2 decides to contribute, and also person 3, etc. So we create all the contributions. Imagine people are paying taxes. Imagine people are giving some amount of money to the neighborhood association, something like that. Okay? This is the total amount of money. And we usually say that, well, this amount of money is going to be multiplied by some constant, and later on going to be shared among the original n people. And in this example, let's suppose that this is 0.4. Okay? Whatever goes to the public account is aggregated, is multiplied by 0.4, and everybody is able to enjoy it. Why 0.4? I don't know. I just have to choose a number. Okay? But this is a more or less reasonable number. Okay? Imagine that if there are only 4 people, let's suppose there is only C1, C3 plus C4. Imagine that the amount of money that goes to the public account is multiplied by 1.6, and later on is divided by the 4 of us. Okay? And this would give you exactly the 0.4. Right? The important thing is that this multiplier here, before we compute the per person share, is bigger than 1. It's like working together, create some synergy. This amount of money, this aggregate amount, is multiplied by a number larger than 1. Okay? This is how the model is put together. Now let's try to solve it. Okay? what do? Well, as written here, we expect everybody to make a simultaneous decision about how much to contribute and how much to keep in his or her pocket. So let me write personal profits. This is a capital Pi from the Greek alphabet. This is what we typically use as notation for profits. This is profit for person 1, when this person decided to contribute C1 units of money, and the other people decided to contribute C2, C3 up until Cn units of money. Clearly, your happiness, your profit at the end of the day does not only depend on what you contribute, but it also depends on what your neighbors are doing, what the other citizens in your society are doing, right? Now let's see what happens. On the one hand, we have some amount of money from the private account. You decided to keep 20 minus C1 units of money on your private account. That's something that you can enjoy directly. Okay? But there is also money coming from the public account. And as I told you, even if you don't contribute, no matter actually how much you contribute, you are entitled to 0.4 times the total sum. And remember, your contribution is there. So it's your contribution C1 plus C2 up until Cn. Okay? This is your profit function. I know it sounds maybe too abstract, or maybe you don't like mathematics, but I always tell students that, well, mathematics is just like another language. To me, it's easier to read this than kanji, for example, right? And the same idea, you just explain everything in a clear, concise way. All right. We have our model. We know what the decision maker cares about. Now, all we need to do is to make sure that the decision maker is doing his or her best. We have to maximize that function by choosing the contribution level CI. Okay? I will ask you in a moment, actually, how much you would want to contribute. But let me tell you what game theory, what microeconomics would suggest you to contribute. We just need to maximize this function. And before doing that, don't worry, we don't need calculus today. Let me just put the C1s together. Here I have C1 multiplied by 0.4. Here I have C1 multiplied by minus 1. So at the end of the day, this is like minus 0.6 times C1 plus, and I will put the rest with blue because it's actually not very, very important. Here we have a 20, and then here I have 0.4 times what the other people, person 2, person 3, up until person n, decided to contribute. Is this clear? So this is the part that actually depends on you. This is the part you have full control of. This is the part that you decide. The rest is decided by others, by your neighbors. And this is a simultaneous, this is a joint, this is a simultaneous decision problem. It's not a joint decision problem. Everybody is deciding how much to contribute individually. Okay? Now, even if you don't know much mathematics, I'm sure that you can see that in order to maximize that function by choosing an appropriate value for C1, we get this very pessimistic result. C1 should be equal to 0. Because any unit of money that you contribute to this public account in this setup will just reduce your happiness, right? It has a negative sign. So if you want to maximize this function, by choosing a value for C1, you would say, let me choose the smallest value. It should be a 0. If you'd like to go, in a more intuitive way, you could also say that as an investment, if I leave, in this example, money on my private account, the return is 1. It's positive, right? But it's not there is no positive interest, but at least I have what I keep there. The public account actually gives you this negative return at the end of the day. Any amount of money, each and every unit of money that you put there, will actually reduce your personal profits. And for that reason, theory suggests that nobody should contribute. And that's, of course, very, very pessimistic. It's of course, a very negative result. Why? Because if nobody contributes, let me put it like this, then the profit of person 1, but every other person will have the same profit. So if nobody contributes, C1 is equal to 0, C2 is equal to 0, everybody says 0, then your personal profit is just a 20. You don't work with your neighbors, you enjoy your initial endowment, that was 20. But if you do contribute everything, for example, and everybody else is contributing everything, then what would we have? We would have here n times 20 multiplied by 0.4, right? How much is that? It's 8 times the number of people, n. And as soon as there are 3 or more people, you can see that for society, it's actually better to work together to contribute to the public account, because 8 times 3 is 24. It's more than this 20 that you could get. So this is the social dilemma. This is what social scientists, economists, political scientists, and other social scientists are so worried about, especially because the theoretical predictions are so extreme, so negative. Okay? Now, having this prediction, of course, there is this obvious question. Is it really the case that people never contribute to the public goods? Just think about yourself. You are too many people. I cannot ask you individually. In a classroom, sometimes I ask, or we use phones, and then you can send me your message, and I can quickly aggregate and display everything. Just think about how much you would contribute in such a situation. Okay? And let me show you what typically students do in a situation like this. These are very famous, very well-known results from the experimental literature. It's a paper written by Ferenc Veszteg, and it was published in the year 2000. What they did was to invite 112 students from the University of Zurich in Switzerland to a computer lab. That happened in 1996, long time ago, in January, February 1996. They formed randomly groups of 4 people, of those students, and they asked them exactly this question. Imagine this is the setup. Imagine you live in a mini society of 4 people. Imagine you have 20 monetary units. You can decide how much to keep, how much to contribute to the public account. Please tell us. What would you do? They asked students to repeat this interaction for 10 times. It was stranger matching. It means that your group was changing all the time. Today, in the first round, these 4 people are working together. But then for the second, third, etc. round, everything is reshuffled. You are very likely to interact with other people. And they were doing it for real money. Okay? It's not just hypothetical choices. In experimental economics, we typically use real money as monetary incentives. Now let me help you to make sense of the pictures. Look at this, what happened. It says without punishment. We'll go to the punishment part. At the very, very beginning, students on average decided to contribute 6 out of 20 tokens. Well, what do we say about this? It's a little bit like, the glass is half empty, the glass is half full situation. 6 is more than 0. So maybe you can say that economic theory is too pessimistic. People are nicer than economic theory suggests. Look, they are contributing on average 6 instead of 0. But 6 is not 20 either, right? And it's actually further from 20 than from 0. And as you can see, as interaction is repeated, as you go by, as you see that other people are free riding, the average contribution level goes down. And by round 10, actually the contribution level is just 2%. It's 10% of the initial endowment, right? And this is a very typical result. It's not just a very weird, it's a very special feature of the game that they used. Later on, other researchers replicated similar situations with slightly bit different parameters, and we typically get this negative trend. Okay? People start out contributing significantly more than 0, but as time goes by, contribution decays. The nice thing, and that was also in my title, is that in spite of this hopeless situation suggested by economic theory, it seems that societies around us are able to solve the social dilemma. How do we do that? Well, we punish. I think, Japan is a very, very good example for that. If somebody does not obey certain rules or certain norms, punishment will follow. And it doesn't have to be the police force. It doesn't have to be the authority. Sometimes punishment is happening among peers. You do something that is not in line with the expectations, with the social norm, and then your friends, your schoolmates, maybe your professors, but somebody in the society around you will punish you. So that's exactly what Ferenc Veszteg tried to suggest. What they did was to create another situation, a little bit different model, in which decision makers were allowed to punish anyone in a costly manner. Costly manner means that both parties will have to pay. Okay? So we play this game, and after we decide how much to contribute, there will be a chance for everybody to punish anybody else. Okay? If I play this game with the three of you, let's suppose I contribute just a 4. You observe that, and then you have you have another decision to make. You can pay 1 monetary unit in order to destroy 3 monetary units from my account. It's like punishing me if you just shout a harsh word at me, for example. If you just say, hey, this wasn't really nice. Okay? It will cost you some amount of money. It's not easy to speak up, but it will hurt me more, right? 3 times that much. That was the idea that they did. Okay? And as I said, everybody was allowed to punish actually anybody else in this setup. And what you have here with the white dots, is the original game without punishment. And with the black dots, you have results, average contribution levels, when punishment was available. And you can see that the picture is much nicer, right? I mean, they did, both orders. So first they did the game without punishment, then with punishment, and then they did the other way around. But the results don't seem to change much. As I said, if there is no punishment, people start out contributing somewhat, positive amounts, but then there is a decay, there is a tendency, a negative pattern here. But when there is punishment, look at this, the contribution levels increase. Or here, they remain at a relatively high level. It's around 12 tokens out of 20. That's 60%. It's not 100, but it's way further away from this theoretical 0, right? Now you can say, all right, this happened in Switzerland. Switzerland is a strange country far away in Europe. Can we expect something similar if we go to other places? And that question was answered by Veszteg and some other people. So Veszteg was also on this first paper. And here I'm showing you the main results from another paper published in 2010. Veszteg with 2 other researchers. What you have here is a figure with 6 categories. Okay? For example, here you have what they call English-speaking countries. There are 3 cities represented here with different shapes. You have Boston from the United States, Nottingham from the UK, and Melbourne from Australia. And you can see that the patterns are really similar to what we saw before, right? If there is no punishment, people start out with a positive level of contribution, but there is a steep negative trend here. And we go to this very, very hopeless situation in which no public goods are being provided. If there is punishment available, peer punishment, people can, in a costly way, but punish each other, it seems that we are able to sustain a relatively high, look at this, in this case, the US, Boston, a very high, 90% level of contribution. Let's move here, Protestant Europe. This is where Zurich and St. Gallen are, 2 cities from Switzerland, Copenhagen from Denmark, Bonn from Germany. The picture is really similar, right? This is my part of the world, Orthodox ex-communist countries. I'm from Central Europe, not my country, but here you have Samara, Minsk, and, sorry, I can't pronounce it. This is a city in Russia today. You have here Belarus and Russia, basically. The picture is much more, pessimistic here, right? Or the conclusions that you can derive from this picture are much more pessimistic. Same pattern without punishment. Punishment does not help, right? Let me skip this. We will come back here in a moment. Southern Europe, even worse. Southern Europe, Istanbul in Turkey, Athens in Greece, very low contribution levels, no matter whether there is punishment or there is no punishment. And what they call Arabic-speaking countries, they went to Muscat and Riyadh, Saudi Arabia and Oman, very similar picture. No matter whether there is or no punishment, contribution levels are very slow, very, very low. Now let's move to our geographic area. This cultural group is called the Confucian group. They had 2 cities in their database represented by observations, Chengdu from China and Seoul from South Korea. Surprisingly enough, these pictures are very, very similar to the otherwise culturally very, very different English-speaking countries and the Protestant European countries, right? No punishment leads to free riding, but punishment is able to sustain high levels of cooperation or high levels of contribution. Okay? You could say, all right, but Japan is still missing, right? And Gechter came to Japan. He approached us, and with a number of people from here, Waseda, also from Keio University and Osaka University, we carried out some experiments. So I can show you results. Okay? But let me tease you a little bit more. I still have 5 minutes. Okay, so where is Japan, right? Of course, Japan is here geographically. You are sitting in Tokyo. But culturally, Japan is a Confucian country, according to social scientists. What you see on this slide is the so-called cultural map of the world. What they do is to use answers to questions in what we call the World Value Survey. They carry out those surveys periodically in many different countries, many different cities. They try to take representative samples of the population, and they create basically a numerical measure of different variables that are a little bit artificial, but they still carry some empirical meaning. What you have here on the horizontal axis is basically a numerical measure of survival values against self-expression values. Let me tell you what they mean. So they say that survival values place emphasis on economic and physical security. It is linked with relatively ethnocentric outlook and low levels of trust and low levels of tolerance. You really just need to fight. You need to survive, right? Self-expression values give high priority to environmental protection, growing tolerance of foreigners, gays and lesbians, and gender equality, and rising demands for participation in decision-making in economic and political life. You don't need to worry about survival. It's more about acceptance. It's more about growing tolerance. On the vertical axis, you have traditional values against secular rational values. Traditional values emphasize the importance of religion, parent-child ties, deference to authority, etc. Secular rational values have the opposite, basically preferences to the traditional values. These societies place much less importance, much less emphasis on religion, on traditional family values, and even authority. You can see that Japan, probably you have found it by now, is here. It's quite an outlier, quite an extreme value in terms of secular and rational values. And it's really in the middle in terms of the survival and self-expression values. Somehow researchers believe that Japan should belong to this Confucian group. Here you have Taiwan, Hong Kong, China, South Korea. But quite honestly, Japan is really far from those neighbors, right? The closest neighbor in this picture is actually Germany, this Protestant European bloc, right? I mean, this could be one guess, but okay, I will not tease you more because I don't have time. this is what happened in Japan. What I did here was to give you as a reference results from China and South Korea, because those are the two cities that belong to the same cultural group according to that cultural map of the world. What you have in black with these black dots is data from Japan. This is an aggregate for Osaka University and also for Waseda. This part of the picture is not very surprising. If there is no possibility for punishment, no peer punishment is happening, participants in these experiments in Japan started out contributing almost half of the initial endowment, but then as we repeated the interaction, we observed a decay. It goes quite quickly towards zero, right? And what is really surprising is this part of the picture. Punishment did not work the same way as it did in China and in South Korea. Look at this. This is quite disappointing, isn't it? The contribution levels, even if we have punishment, start out around 50%. Maybe you could say somewhat less, maybe just, 40% or so. There is a slight increase, but it never reaches the height that we observe in those other cities, other two cities in the same cultural group. And it remains more or less constant, and there is even a small decay there. Let me put the Japanese data in this other picture, Protestant Europe plus Japan. In color, you have Protestant Europe. Again, in black, you have Japan. It's quite surprising, isn't it? Actually, even get there, as an outsider to Japan, you would expect society to work very well together, people to contribute, and people to punish each other when contribution doesn't reach the expected levels. But what we observed in these experiments is pretty much against what we expected at the beginning. And we had enough data. It cannot just be that we had an unlucky day and we invited some strange people. We actually have quite a few observations behind it. Statistically, these are significant differences. We have done that part of the exercise. And my time is up. So I have to leave you with these questions. So why is Japan different? And I honestly don't know, and we don't know. If you have an idea, this is my email address. Please send me email. We will give you full credit, really. I'm not really sure how to explain this. Okay? Well, thank you very much for the patience and for being here. If you have questions, approach me directly, or my colleagues. You can also send us emails. We have also an information booth. And I wish you all the best, okay? Thank you.